Welcome and settle in as we spend a quiet day and night in a laboratory where ancient ice speaks in millimeters, where isotopes murmur like a low wind through long corridors, and where calibrations stretch out in steady, drowsy lines. Before we begin, if you enjoy drifting off to calm science, a gentle reminder to like this video and subscribe, and feel free to use the mellow playlists in the description to keep learning softly as you fall asleep. What city, country are you watching from right now? Imagine yourself arriving very early, before the sun has pushed a full glow over the building, with the hallways still and the echo of your footsteps softened by carpet and the hush of the air system. A badge opens a door with a quiet chirp, barely louder than a whisper. The lab has a faint scent of clean plastic and filtered air. You pause at the coat rack, slipping into a smooth lab coat washed to a textile hush, then into a pair of pale, powder-free gloves that fit with a gentle stretch, snapping into place so lightly it barely disturbs the stillness. Picture the room around you, with stainless steel benches that reflect the cool light in a muted way, monitors resting like small lakes of grey, and instruments slumbering in standby. The mass spectrometer, the chilled auto sampler, the laser cavity ring-down analyzer, and rows of boxes with barcodes that look like the quiet stripes of a sleeping zebra. Imagine the cold room beyond, behind a thick insulated door, painted white and slightly frosted at the edges. Inside, the temperature holds steady and very still, a small world at -20 degrees. A faint cloud forms with each exhale, then drifts out of view like a thought you can let go of. Shelves stacked to shoulder height with slender tubes of ancient ice, called cores, wrapped and labelled, millimetre marks along their length like a measured song. You roll a cart into the cold room. The wheels make a soft, rubbery sound on the floor, and then are quiet again. The overhead light hums with a note so even that it almost disappears. On a smooth table in the cold room, there is a microtome set for ice, its blade calibrated to take slivers in delicate sheets thinner than a fingernail, some as thin as paper, some a little thicker, depending on the slow rhythm of the plan for the day. You open a tube and see the core, pale and faintly blue. It has travelled from a remote plateau, from a station where the horizon runs into itself in a circle of snow and sky. But here, it is as still as sleeping glass. The surface glints with tiny crystals that look like a dusting of stars, and inside are pinpoints of ancient air, thousands of small beads that hold the breath of years. You place the core into a holder, tighten a screw very slowly, and listen to the quiet, tactile feedback of metal threading against metal. The tune of the cold room, the hum of the light, the soft whisper of your sleeves when you move, becomes a low lullaby. You trim the end first, a careful cut with the microtome, the blade leaving a surface that is silk smooth. With a whispering sound, like a page turned with gloved fingers. Small shavings curl to the side and drift to a waiting tray like gentle snow. The lighting shows faint bands in the ice, a pale winter, a brighter summer, a fine dust layer, and then another winter. The years here are so thin they become millimeters, and the way you slice the core acknowledges this quiet precision. The thickness repeats, season to season, ready to be read by conductivity, by dust, by isotopes of oxygen and hydrogen that shift in delicate ratios according to the coldness of air, the pathways of clouds, the fractionation that happens as moisture moves from ocean to sky to snow. You hold the plan in your mind without hurry, millimeters to the isotope analyzer, millimeters to dust counting, millimeters to electrical conductivity measurement, millimeters reserved for later. The sample chain logged in the computer with a barcode scan that beeps softly, then falls away into silence again. The morning in the lab opens like a measured sequence. You place the cut slices into small vials made of clean glass, capped, barcoded, arranged in a neat numerical story. This story will run through instruments piece by piece, a slow procession. You place a few standards among the unknowns. Small volumes of water, labelled with names that are quiet and steady, with internationally used labels that make the world of labs feel connected. These standards allow you to tie the numbers in this room to numbers in other rooms, near and far. In another corner of the lab, the isotope analyzer warms gently, its lasers circling, its cavity reflecting light over and over so that absorption can be measured as a careful signature. In another room, the mass spectrometer's pumps establish a steady vacuum, a distant hush like someone breathing under a blanket. Imagine a page on a clipboard where you write the plan for the day in tidy lines, or type it softly into a lab notebook on a screen. A line for each file, a time, a reference standard, an instrument assignment. There is something soothing about the orderliness of the columns, the aligned digits, like small stepping stones crossing a very still stream. You test the microbalance, letting a weight rest and settle, the display digits stabilizing, the drift minimal, quieting the numbers to a steady value. You calibrate a pipette with a slow rhythm, draw, dispense, weigh, record, repeat, ensuring each microliter lands where it should, that each droplet is an echo of the last. You walk to the laminar flow hood where dust counts will be done later, its fans smooth, pulling air downward with a constant quiet push, so faint it feels like a whisper against the back of your hands. Wipes soaked in deionized water glide over surfaces, and the scent is almost not there, just a crispness, like walking near a stream on a slow morning. The bottles of ultra-pure water stand in line, their labels straight, their caps snug. The laboratory is clean, but in a calm, lived way, not clinical in a sharp sense. Papers lie in stable stacks, pens in a cup, a mug holding a bit of warmth from earlier. faint tea leaves resting against porcelain. Now imagine we are in front of the cold room again, and you are slicing off another millimeter of the core, millimeter by millimeter, with the same patient motion. The blade slides through without hurry. Each slice is a date. Each date is a breath of temperature, of cloud path, of regional stories reduced to the soft language of isotopes. Oxygen and hydrogen move in water molecules that have identical shapes but different weights. The slightly heavier ones, carrying an extra neutron, hold back a little when clouds rise up slopes and cool. They fall a little sooner. The light ones drift a little farther. Over and over, journeys occur, gently recorded in snow. The ratio between these heavier and lighter cousins tells us about air that was a little warmer or a little colder, air that came from a different path across the sea. The meaning remains quiet, quantitative, never insistent, never noisy. It is a whisper you can lean closer to if you wish, or let blend into the background while your eyes relax. On the bench, you line up the vials for isotopes, another set for ions, another set for gases. The gas work will wait until the afternoon, when the crusher is available, the polished steel jaws ready to crack open a piece of ice and harvest the tiny bubbles inside it. Those bubbles carry methane and carbon dioxide, not as words, but as numbers. They are small but clear reflections of how air has changed over long times, smoothed by snow accumulating year by year into fern, into ice, compressing the spaces that hold breath from days gone by. That story is worth reading with care. But now the story is quiet and patient, waiting to be told over hours of steady measurement. You step into the isotope room. A gentle light lies over the analyzer, and the screen shows stable baselines that move in a calming way, like the surface of a lake barely stirred by a breeze. The auto-sampler carousel turns by nudges, placing each file under a needle, taking a small sip of water and offering it to the cavity where laser light resonates and fades. There is a sound of air valves in the background, a soft tick as each one opens and closes. A green dot pulses slowly on the display to indicate the rhythm of ring-down events, each one a measurement of how the light lingers and is absorbed by isotopic species in the water vapor. As it cycles, the numbers arise on the screen in a column that grows without fuss or rush, line by line. The standards bracket the unknowns, one before and one after, and as the hours pass, the instrument drifts slightly and is brought back gently by these references, a slow correction that cushions the data. You check an Allen variance plot to ensure stability over the integration times you use. But this is a simple glance, a reassurance more than a worry. The column of values is quietly consistent, and the whisper of the isotopes translates into digits that have a satisfying order. You pause to sip warm tea, holding the mug in both hands, feeling the warmth travel into your fingers, noticing the contrast with the memory of the cold room. The warm and the cold remain in balance, just as the work moves between them with a nearly imperceptible sway. Further along the corridor, another instrument awaits setup for electric conductivity measurement on a thin ribbon cut from the core. That ribbon will pass under electrodes that touch lightly, recording variations that track acid layers from old events, gentle peaks marking periods that help to align the core's depth with a calendar. The current will be tiny, the signal soft and full of structure. You lay out the path of the ribbon, smooth and straight, and cover it with a light plastic hood to protect it from the room. You let it sit for a moment, a little diapause, as if the ice is collecting itself before speaking in numbers. Now, back in the cold room, you mark segments with a pencil that draws a faint grey line on blue-white ice. Each mark is a depth, a coordinate in a slow, tidy map. A barcode scanner reads labels and places them into a database that grows by small increments, each entry like a heartbeat. Locking lids click with a smooth sound, never harsh. You stand still for a breath and let your eyes relax on the pattern of frost on the door, an accidental crystal garden that repeats triangles and hexagons with pleasing symmetry. Even the small noise of your breath seems quieted, as if the room is made of soft snow. The isotope data accumulate. Every so often, you check the simple graph that shows the ratio numbers rising and falling with the seasons in the core slices. Peaks where summers were, valleys where winters lay. Over longer reaches, the whole trace drifts gently upward or downward, reflecting larger patterns, the kind that tie into changes in ocean temperature and circulation. You do not need the grand story all at once. You let the graph be only what it is, a calm line that moves across the screen at an unhurried pace. Midday approaches, and with it, a small break. You step outside the lab into a quiet lounge where a wide window overlooks trees that sway slowly. A thermos lid unscrews with a soft twist, and the scent of soup rises in a comforting way. A sandwich rests in waxed paper that opens with a gentle riffle. You think about the afternoon steps with the same patience you would apply to a puzzle, not to complete it quickly, but to experience each piece as its own small completion. The mind finds a restful rhythm in such sequences. You take your time, savoring the warmth, and then return to the lab with a sense that the afternoon will pass in a series of soothing motions. Now comes the gas work, to extract the tiny, ancient air from the ice. You carry out a quiet ritual. The crusher, polished and heavy, sits like a calm animal. You place a small piece of ice into its chamber and seal the lid. A vacuum pump creates a hush, and sensors indicate that the space inside is clean. At a steady pace, the crusher lowers and cracks the ice without drama. The sound is soft and controlled, more like a pressure settling into place than a snap. The released air is directed into a small loop for gas chromatography, where it will be separated into components and measured. The flow, measured in gentle milliliters per minute, is stabilized by mass flow controllers that adjust silently. The chromatograph's oven holds its temperature with a constancy that you can almost feel, a warm stability that supports separation. Methane peaks appear on a screen as small hills rising from a baseline that is smooth and nearly flat. You note the retention times and the peak areas. Compare them with standards that were run earlier and will be run again later for bracketing. The numbers find their place beside isotopes and conductivity. Everything is slow and deliberate. Many strands of one woven cloth. You think about how the bubbles were once part of a cold morning long ago, how the air that you measure was once breathed, then compressed and kept safely in the ice, carried through time and then opened here. That thought feels both immense and light. You let it float and dissipate in the same way that distal hum from the vacuum pump seems to blend into the room. As the afternoon extends, you turn to dust counting. A melt of a measured volume passes through a tiny flow path, illuminated by a soft beam of light. Particles scatter the light in small, predictable ways, and the instrument counts them, categorizing by size ranges. The display moves incrementally, and you keep an eye on the blank runs that, in their flatness, bring a certain comfort. Low backgrounds are like a calm sea. If one blank shows a stray particle count, you loosen a fitting, wipe it down, and then the next blank returns to that reassuring level where uncertainty is gentle and manageable. Standards are run again. A few more vials of known isotopic composition pass through the analyzer, and you see the instrument's tiny drift corrected by a curve that settles like a cushion under the data. The numbers adjust a little, then find their resting positions. You print a short report or save it as a digital note. The data are more memory than event, more a library than a performance. You feel the soft satisfaction of knowing the measurements are anchored. You may imagine the way a day in the lab is guided by time on each instrument. Slots open and are filled, then lead to others. A colleague passes by with a nod, then moves on to check the ICP with ions. Simple small talk occurs in low tones, a few words about stability and sample counts, a mention of a shipment arriving in the morning, and then stillness again. You wash a set of bottles with a gentle swirl of water, cap them, label them carefully with a fine tip marker that lays down an even line of ink. The caps tighten with smooth resistance, then stop. You place them in a rack that looks like a tidy small city. While the last set of isotope samples runs, you take a moment to retune the cavity alignment. On the screen, the intensity trace shows a slight increase when the mirrors are adjusted, and the quality factor rises. The ring down times lengthen in a stable way. You note the time, note the change, and feel a small sense of alignment. The instrument is not a noisy machine here. It is a quiet companion, predictable, thoughtful in its own mechanical way. You clear a few dust particles from lenses with gentle air, careful and slow, not to disturb the calm path. You turn back to the cold room for the late afternoon. The The temperature remains unchanged. The core stands waiting. You slice a few more millimeters, each one placed in labeled vials, each one entered into the list. A freezer holds others, frost curling at the edges of the door frame like lace. Inside the cold room, time feels slightly slowed, as if the cold has asked everyone to speak more softly. You think of the journey of the water molecules, evaporated, drifted, condensed, fell, pressed into fern, closed into ice, carried downward by accumulation, held for centuries or millennia, then finally lifted out by a drill. It is an old journey, and yet here it is, present and serviceable, ready to become data. Before you step out of the cold room again, you rest your hand on the card handle, feeling the low temperature through the glove, a careful chill. You push the cart along the corridor in a slow glide. The wheels turn easily. A door opens with a sound that is both soft and definite. The corridor air is warmer, and a slight mist of breath vanishes quickly. You move the samples to the bench, and then back to the analyzer readout, then back to the bench, then to the logbook, and the loop is restful. The gentle rhythm continues. In the late daylight, you review the growing archive for this core section. The digital overview shows row upon row of entries, each row a sample, each column a property. The lines are neat. The eyes can wander over them and find no emergencies, no interruptions, just a steady build-up of record. You consider age depth modelling a later task, where the fine seasonal variations will sit within larger alignments, made with markers like acidity peaks and small flakes of volcanic glass found by others in neighbouring slices. This is the subtle structure of time in ice, assembled from many details, each one measured with care. You imagine the age of a slice, computed to a narrow uncertainty band, with a confidence that rests on the quiet idea that what is measured consistently tells a shared story. The mass spectrometer room down the hall holds a different but related kind of silence. You step in and hear the deeper hum of pumps, a sound that is steady, gentle, slightly lower in pitch, like a slow ocean heard through a window. The filament is set at a low current, ready to ionize molecules with a touch, while the detectors wait. A quick test solution runs to check calibration, a set of known isotopes, and the instrument settings are trimmed until the ratios sit where they should. The baseline flat and calm. You enter the last few settings with light finger taps, gloved, low, and then you step back to let the machine run. It does not draw attention to itself. It simply continues, and you are the person who tends, observes, and translates. As evening creeps like a folded blanket over the building, you tidy a bench, stack labware, rinse a few items, wipe the surface in straight lines with a clean cloth. A pipette stand holds slender barrels upright, their tips removed and disposed of. The lights are a touch warmer now, less daylight and more evening glow. You bring out a small notebook with equations sketched gently, not to compute anything strenuous, but to hold simple thoughts about fractionation. In very general terms, You remind yourself that heavy and light isotopes separate a bit when phase changes occur, that the degree of that separation depends on temperature, that this is the gentle core of why the ratios you measure can become pale thermometers of past air and ocean. It is a reminder more than a lesson, and the mind receives it without strain, as you might receive a story heard many times before in a familiar room. You check the instrument one more time. The auto sampler lifts another vial. The needle dips. The loop fills, and the analysis moves forward. The numbers appear again, like small birds landing on a wire in sequence, each one similar, each one quietly different. You plot one small graph of daily performance, a ritual that says the day was stable, that tomorrow will start without surprises. You breathe in slowly and deeply, then let it go softly. The building has settled into its night posture now. The background noises are more consistent, fewer doors, fewer footsteps, more stillness. This is a good time for long calibrations, the ones that do not need you to hover. You begin a stability run on the isotope analyzer, allowing it to cycle through standards for hours, documenting drift and memory, mapping out the gentle tides of its behavior. You set the mass spectrometer to run a tune set overnight. You cue the dust counter to process a set of plain water blanks in slow succession. The result will be a long line of zeros and small numbers, pleasingly uniform, a comfort to greet in the morning. How sleepy are you on a scale of 1 to 10? As the night lengthens, imagine yourself walking the lab slowly, as if through a museum where everything is sleeping. The cold room holds its frost and its still air. The instruments hum. A small desiccant canister shows a pale color that means it is not yet saturated. Power strips glow with tiny dots. The refrigerators for reagents whisper. Notes pinned near instruments are crisp and aligned, and the ductwork overhead carries a soft current that keeps the air even and gently moving. You sit again with the isotope numbers, not to press them into meaning, but to see their shape. Light, heavy, light, heavy, like a calm sine that extends and is modulated by broader arcs. At the edges, your mind begins to float, to drift into thoughts of cloud paths you have seen on weather maps, cloud paths you have walked under, the way a gentle rain has its own rhythm on different roofs. You think of how a storm far away would never know it is giving a tiny signal to a laboratory that will stand in another time and listen. You let this idea become abstract. Then the abstraction becomes texture. And then the texture becomes almost nothing at all, a field of softness. In the notebook, there is a page where you sketch a simple Rayleigh distillation line, a gentle slope that says, as air masses precipitate moisture, the isotopes change in relation to what is lost. You draw the axes without labels for now. You do not need them here. You mark a few points with tiny dots that look like stars through fog. Then you close the notebook and rest your hand on it as if to feel the calm contained within. In the late night, a colleague texts a brief note to say the truck with insulated crates should arrive in the morning. The crates will hold new sections of core from slightly different depths, from a portion of the ice sheet where dust is a touch higher and layers a little more distinct. You imagine packing materials, the hush of dry ice, the faint breath of vapor that rises when the lids are opened. You imagine how the new material will slide into the current plan, not in a rushed way, but like a quiet new chapter that will be there when you turn the page. You walk into the room with the electrical conductivity set up, and the thin ribbon of ice has been run and is now resting, a slender line of wetness evaporating under the hood. The trace shows small undulations and a few gentle peaks where acid layers once drifted down and fell, then were preserved. The data clip into the larger set, forming a place where later a tie point may be found, where a peak matches known events preserved in other archives. The way these alignments work is steadied by probability, guided by knowledge, but never forced. You let the thoughts settle and drift. Down the hall, windows look out to a night sky. A soft glow hangs over the horizon, perhaps from a distant neighborhood, and a few stars punctuate the dark in a quiet way. The lab reflects this, holding tiny points of light. You turn a dial slightly to adjust a flow, the movement smooth and precise. You watch a pressure gauge sit at its chosen value and not move. The stillness is a teacher here, not a silence. It has a content, but that content is felt more in the body than in the mind. A relaxation that allows attention to soften. You take a blanket from a cabinet and set it over a chair near a monitor where a long calibration is running, not to sleep, but to rest while you remain present. Your eyes follow the slow scrolling of time on the screen. The noise of the instrument is low. The numbers float across in a line, a few decimals, repeating, drifting. If one drifts a little, it recenters with time. The longer you watch, the more the data behave like themselves. Not dramatic, just themselves, exactly as they are meant to be. You recall how each millimeter slice of ice can represent days or weeks or months. In some parts of the core, 1 millimeter may be a snow season, in others, several years. It depends on where the ice formed, on how accumulation behaved. The way the drilling moved through layers has a soft memory too. This is why labels and depth records and coherent logging matter. This is why the long calibrations matter. They bind the numbers to the place and time that the ice has brought with it, so that when, much later, a figure is drawn or a line is placed in a publication, the numbers are not just numbers, but measured whispers that are faithful to their source. Overnight, the laser analyzer cycles through another standard and another, and you make small notes in a log at regular intervals. Each note is a sentence fragment, precise, short, calm. The mass spectrometer moves through its tune, adjusting lens voltages, optimizing again and again until it reaches a plateau of stability. You watch this plateau appear and hold, like a sunrise that stops at dawn and stays there, unchanging, a gentle stasis. A drawer holds tools lined up on a foam insert, tweezers, small screwdrivers, a spare blade, a lens cloth, a bottle of clean air. You lift the tweezers and feel the small weight. You return them and they sit perfectly flush in the cutout. The order is restful. It lets the mind trust the motions of the hands. There is nothing to hunt for, nothing to find other than what is already in place. You loosen a fitting, reseat a seal, calibrate a thermistor in ice water that sits right at the familiar freezing point. The readout aligns with the known temperature and holds there, steady, like a pause in a sentence before a gentle continuation. At some point, you step back into the cold room again. The breath fogs and then disappears again. You mark a few new cuts to be ready for the morning. You consider a cross-section to be saved for imaging, a thin slice to be placed between glass, to be examined under a microscope where air bubbles are tiny orbs and a few dust grains look like grey planets. The idea feels like something to look forward to without urgency. You return the core to its wrapped cradle and note the position. You can imagine that late at night, when the building is quiet, the isotopes themselves would sound like they are whispering. Not literally, not in any sensible way, but in the mind. They whisper in a gentle rustle. The whisper says that heavier ones linger when lighter ones fly, that temperature guides how far each will travel, that the dance is always balanced and without strain. The whisper says that the millimeter you cut today has a specific place in time, and that your careful act of slicing respected that place. The whisper says that calibration is not a chore, but a long lullaby you sing to the instrument and to yourself, so that both are at rest and aware. If you choose, you can think about diffusion in fern, the way the air mixes in the layers before the pores are sealed off into bubbles. That mixing blurs small details, like a finger drawn lightly across wet paint. It is not a loss, but a transformation into a more stable form. The later extraction of gases is therefore a reading of a softly smoothed history. You accept this gracefully. Each archive has its voice. Each voice has its pitch. You match your listening accordingly. In the changing hours, the body feels the weight of time, and you allow a long stretch of back and shoulders, a gentle twist, never sharp, then a slow, deep breath. The lab receives this quietly. A clock ticks in a slow, almost imperceptible way. A monitor cycles through a screensaver of muted colors, but you turn it off and let the room grow still again. The instruments continue their gentle work. You sit and rest. Toward morning, the long calibrations are close to completion. The data form a neat sheet you will review with fresh eyes. You prepare a small breakfast at a side table, a bowl of yogurt, a sprinkle of oats, a spoonful of honey, and you take small bites mindfully, aware of the simple sweetness and the soft hum of the room. You clear the dish Wash it carefully and set it to dry. The sky beyond the windows palens and a mute blue enters the lab. You switch off one desk lamp because it is no longer needed, and the light from outside becomes the room's main source. You print an overnight summary, a single page, narrow margins, labels aligned. You hold it in your hand and feel the slight warmth from the printer, then let it cool and place it in a folder. The overnight blanks remained low. The isotope analyzer held its alignment with a drift of a few tenths that will be accounted for by the standards. The mass spectrometer tune is complete. The dust counts are flat and soothing. The unexpected did not appear. You are grateful for the quiet. At this point, you are ready to welcome the morning's small bustle. You begin by checking the cold room inventory and then step out into the hallway, where a wheeled dolly carries 2 insulated crates. You sign with a pen whose ink flows without interruption, then lift the lids. A moment of fog rises and is gone. Inside, the core segments look familiar, carefully wrapped and clearly labeled. You transfer them to their shelf positions with slow, unhurried motions. The packing materials fold into a neat stack to be reused later or recycled appropriately. You record all of this in the log, scanning barcodes that beep like tiny birds greeting the new day. You plan the next sequence of cuts, aware of the time you have before the instruments will be ready for another batch of samples. You clean the microtome blade with a soft cloth, then install a fresh one with a gentle screw turn, a motion that you perform with eyes half closed in comfortable practice. The blade edge is bright, sharp enough to divide a micron-thin slice without complaint. You place a core segment into the holder and begin again. The first slice lifts away in a smooth arc. The second slice does the same. The gentle rhythm continues. By mid-morning, the lab is in full but soft motion. The isotope analyzer is ready for a new tray of vials. You fill the tray slowly, placing each vial into its circular seat. The labels face outward like guests at a small table who all look toward you, willing to be understood. The instrument cover closes with a subdued click, and the sequence begins with the same green pulse showing that ring downs are ongoing. You prepare a fresh set of standards to bracket this run, placing a cold bottle under a laminar hood, letting a few droplets condense into a clear glass vial, gently swirling it, and then capping. Temperature is logged with a small probe so that the standards are used in a well-known state. You note the brand of scepter, the batch of vials, the cap type, and any minor detail that will help if future scrutiny is needed. It becomes a form of mindfulness, a recognition that small care now creates future calm. At the dust station, you process another melt. The instrument's internal pump makes a faint sound, almost not there. The particle size distribution emerges with a calm curve. You think about the distant storms that once lifted dust, and how those storms might have a slow, periodic behavior depending on the state of the land and the winds. You let the thought linger, Then release it. The data find their way into a clean spreadsheet where each row feels like a soft footstep on a long path. In a quiet adjoining room, an imaging setup shows you a frost flower array on a piece of test ice, not from the ancient core, but from a controlled freezing of clean water. Under moderate magnification, delicate dendrites stretch in symmetrical arms, a training pattern that reminds your hands of how to hold the slide, how to adjust focus by fine increments, how to press a camera shutter so lightly that it is more of a sigh than a press. You imagine doing this later with a thin section from the core, mapping bubbles and grain boundaries, perhaps measuring the size distribution of crystals that reveal how ice has grown and changed with age. But now, you simply let your eyes rest on the delicate structures and then look away softly. By noon, the lab has a steady flow. A colleague says a few kind words about the overnight stability. Another offers you a cup of warm water or tea. The conversation is slow, friendly, and short, because neither of you want to break the sense of quiet efficiency that has settled over the place. You return to your bench and sort a few prints, clipping them together with a smooth binder clip that closes with a gentle snap. You file them in a drawer that slides without friction, and then you turn back to the isotope monitor where the next number has arrived, barely different from the last, then different again, in the way a breeze varies slightly in otherwise still air. Once more, you calibrate a thermometer probe by placing it into a bath at known temperature. Ice and water swirl quietly, and the value readout settles to the familiar constant that tells you everything is on scale. You note a small offset and adjust it. The new readings please the eye with their closeness to true values. You move to another bench and check the date on a bottle of standard. You prepare a replacement from a fresh file and then return the older one to a storage place where it will be used for less critical checks. The labels line up. The mind drifts. The afternoon returns to the gas line, where you take a few more captures. The ice pieces break in the crusher again, with that same soft, well-controlled sound. The chromatograph shows the gentle peaks, and you are able to relate them to yesterday's entries with the light sense of continuity. The methane levels match what you expect for this depth range. The carbon dioxide concentration falls into the expected band. You do not try to find more here now. The work is to measure, to record, to be present and consistent. The meaning accumulates on its own when the data are together. A small error flag appears on the screen of a different instrument, a benign one. You acknowledge it and check the manual. It suggests a pause and a restart of a module. You do so calmly. The module restarts. The flag disappears. A note is made in the log. Your breath remains steady, your posture relaxed. The instrument chimes in a friendly way when it is ready again. You resume the run and feel a quiet confidence in the system. The lab is a place where small deviations occur and are gently guided back onto track. The long calibrations begin again. You schedule another extended run of standards to continue building the stability map for the isotope analyzer. This time, you vary the order slightly, just to ensure that memory is well characterized. You adjust the wash times between injections to see that the carryover is reduced to an acceptable low. Results appear with simple clarity. Carryover is minimal. The wash is effective. The data are robust. You allow yourself a small smile that feels like a simple exhale. In the late afternoon light, the cold room calls you once more, and the core continues to offer its quiet pages. The microtome's blade glides. The tiny curls collect like feathers, drifting to a tray. You collect them with care. Some will be melted and discarded, some saved, a few dried for dust tests. You restock the bench with clean towels and wipe the handle of the door, leaving it dry and faintly gleaming. You close the cold room door and for a moment touch the metal surface with your glove, feeling the cold pull across your palm. It is like greeting an old friend. Between tasks, you sit with an older dataset from last season and run a soft model that relates isotopes to temperature using a simple calibration curve. You do not push the model hard. You are not here to squeeze. You are here to let the numbers show their best selves comfortably. The correlation is moderate, expected. You update a plot with a pale line of fit that does not intrude on the scatter points, but guides the eye gently. You note that if asked, the dataset would quietly say that it fits within the larger body of knowledge in a modest and steady way. Evening approaches again. You tidy loose ends. You store what needs to be kept cold. You finish washing what needs to be washed. You label what is to be used tomorrow. The lights dim a bit. The instruments ease into another set of long runs. The sleep work of an analytical lab. You stretch your shoulders once more, and then you take a moment to stand near the window and look at the sky. Perhaps it is cloudy, perhaps clear. Either way, it is a gentle view, and your eyes rest comfortably. You return to the benches and run your hand very lightly over their smooth surfaces, gloved, a gesture of farewell for now. You check that the auto sampler lids are closed, that the vacuum gauges read what they should, that the cold room door is latched. You lock a few drawers, turn off a few unnecessary lights, leave the safety lights on. The lab settles into its evening comfort. The long calibrations begin to sing their lullabies again. The same soft lines, the same modest checks, the same unwavering attention to a stable baseline. In the quiet that follows, imagine yourself sitting beside the machine that listens to isotope whispers. The screen glows with a gentle light. The graphs move slowly. The air is cool and steady. Your breathing matches the rhythm of the instruments. For a moment, everything lines up. Your heart rate, the flicker of a status LED, the scrolling of the values. The gentle rhythm continues. This is not the moment for breakthroughs or announcements. This is the moment for being present and letting a long work do its work. The day in the lab has spanned from early morning to the second evening, a full cycle. You think again of the millimeters of core that went to different stations, how each millimeter was respected and read. You think of the isotopes that told their story with restraint and accuracy, their whisper that never stops, because it is in the structure of water, in the simplicity of phase changes, and you respect them for this. You think of the calibrations that, though long, were not a burden, but a chance to let everything settle into harmony. The instruments hum. The gentle rhythm continues. At the close, you ease back your chair, gather your notes, and place a final slip of paper under a magnet on a board, a simple note for the morning. You walk to the door and hold it for a moment, listening one last time to the layered quiet, a far hum, a near hush, the occasional soft beep. It is all steady. You turn off the last unused light. The lab remains in good order. The cold room remains at its chosen temperature, and the ancient ice rests inside, content for now. You take a step into the hallway, then another, and with each step, the day sets like a calm sun. As you come back to the present, carry with you the sense of a well-kept place and the gentle assurance that the Earth's stories are being tended to by small, careful movements made by steady hands. If this calm journey felt restful, it would mean a lot if you give a like and subscribe, so we can keep releasing soothing science this often. Rest well, feel safe and comfortable, and let the quiet of the lab follow you into a peaceful night.